Good day everyone, my name is Aline Audrey and I'll begin our presentation by discussing the importance of noise measurement and why we chose to focus on college study guiding block 4A. Road traffic noise is one of the most significant environmental pollutants in urban areas, and it continues to be a growing problem worldwide. Despite the introduction of various regulatory policies, noise pollution has not been effectively reduced. This is often due to several factors including the lack of engagement from national governments, inconsistency in measurement methodologies, and the absence of effective measures to control noise. As a result, many people, including students living in residential colleges like College Gading, are still exposed to high level of noise. This exposure can have various negative effects such as disrupting sleep, reducing concentration, and even impacting long-term health. The way we perceive noise depends on its strength or intensity compared to other sounds in the environment. Each noise has unique frequency and loudness, and certain sounds, especially sudden or unpredictable ones, can be more disturbing than continuous, steady sounds. On this slide, you can see a chart that illustrates typical noise levels in decibels, ranging from the soft rustling of leaves at 10 decibel to the loud roar of thunderstorm at 100 decibel. This gives us reference points for understanding the noise level measured in this study. Now, let's move on to the objectives of our case study. The first objective is to identify the main factors that influence noise level both inside and outside college regarding Block 4A. These factors include human activities such as conversations, movement in hallways, vehicle engines from nearby roads, and other environmental noises like construction or birds. By analyzing these factors, we can better understand what contributes most to the noise environment in this residential college. Our second objective is to measure the actual noise levels in and around Block 4A. We use a smartphone application to collect data, ensuring that our measurements are consistent and reliable. It is important to monitor these levels to make sure they do not exceed the limits set by occupational safety and environmental guidelines. Excessive noise can negatively impact students' well-being and academic performance. The third objective is to evaluate whether the measured noise levels comply with the Departments of Environment's DOE standards. By comparing our data to these standards, we can assess if the noise environment at college regarding Block 4A is suitable for both residential living and academic activities.
Moving on to apparatus, we have weather application for measuring wind speed and humidity on the case study, and some meter application for measuring the noise level in building shredding. We also use tripod to hold the measurement equipment, which is mobile phone for a long period of time, measuring the noise levels and wind speed data accordingly to the data collection of needed to gather the result accurately. As for the procedure, first, we set up the measurement equipment and use the weather application to measure the temperature, humidity, and wind speed. Then, we use the sun meter application to record the ELQ and the current noise level every minute. Repeat the process and continue recording data for 40 minutes.
Let's take a closer look at the location where we conducted our noise measurement. College Gading is a student residential college, and Block 4A is one of its main accommodation blocks. The map on this slide shows an aerial view of the area, highlighting the buildings and surrounding environment. This location was chosen because it is representative of a typical student living environment, where noise levels can fluctuate significantly throughout the day. During weekdays, especially in the mornings and evenings, noise levels tend to rise as students are commuting to and from classes, socializing, or participating in college activities. These daily routines contribute to the overall noise environment and can sometimes lead to periods of increased disturbance. For our measurements, we collected data on the 24th of June at 5:44 p.m., a time when student activities is usually moderate to high. The measurement session lasted for 30 minutes and 50 seconds, allowing us to capture a comprehensive snapshot of the noise environment during a typical busy period. Here are the key data points from our noise measurements. The maximum noise level recorded was 76.4 decibels. This is similar to the noise produced by heavy traffic or a vacuum cleaner, which can be quite disruptive if experienced over a long period of time. The average noise was 42.0 decibels, which is comparable to the sound of moderate rainfall or a quiet conversation. This level is generally considered acceptable for residential areas. The minimum noise levels was 13.3 decibels, which is very quiet, similar to the sound of rustling leaves. These results give us valuable insight into the noise exposure faced by students living in Block 4A. Understanding these patterns is essential for recommending effective noise management strategies and ensuring a comfortable living and learning environment for all residents.
Hello, my name is Muhammad bin Sofyan bin Karushidin, and I will explain about methodology in noise measurement. Work procedure of the measurement number 1 is install the sound level meter SLM apps from Play Store or App Store. The apps we use throughout the procedure is DB and sound meter. Next, number 2 is set up the apparatus used both inside and outside the building for the reading. The equipment used includes mobile phone to read the SLM data using a tripod. And lastly, number 3 is we then collect the data from the inside and outside the college resident. Next, we will move on the step of precaution. The first one is like professional data reading. Since the equipment that we use the mic reading wasn't a professional level, we questioned and the validity of the reading. However, we proceed and conduct the reading as planned. Just as before, we thought the equipment might not be the 100% precise. There must be a reason for the having SLM apps and the other weather apps available in the App Store. The second is environmental interference. We face challenge during the noise measurement test that is environmental interference, especially outdoor wind transportation, the sound of people talking and changing weather pattern may all interfere with the accuracy of the measurement. Wind can introduce extraneous noise into the microphone and background sound might become the mix up with the target noise, making it difficult to take accurate data. The third and the last one is low input on traffic noise. As it is getting late, we don't have many cars coming in and out the area. The noise input is low at the time we conduct our study, so there are no big change in the data reading. But we just go on in our reading until it serves all the objective needed for our case study. That's all from me. Thank you.
Hello everyone, my name is Vivin Natasha. So in my part, I'm gonna discuss about data collected at college regarding Block 4A. As you can see in this table, we can see the sound level readings that were taken at 1 minute interval from 5:30 p.m. to 6 p.m. At the start, at 5:30 p.m., the sound level was recorded at 41.1 dBA, and the average lag during the 30-minute period was 41.4 dBA. So, in this table, we can see the highest noise level recorded was at 5:59 p.m. reaching 71.5 dBA when a car passed by. Light rain was also present during the measurement, but it only adds soft background noise and didn't significantly impact the average. This data shows that the college regarding Block 4A generally quiet and calm during the measurement period. Next, I'm gonna discuss about schedule of permissible sound level. In this case study at college regarding Block 4A shows the permissible daytime noise level for noise-sensitive areas such as school and hospital is 50 dBA. Since college regarding is located in a low-density residential and institute area, it falls under this category. This location is also a student residential zone and between 5 p.m. to 7 p.m. Many students are returning to their dorms, some are relaxing at the lobby, and some may be jogging nearby. Additionally, Grab delivery rider may contribute to the noise level when delivering food. All of this activity can influence the measurement and should be considered when evaluating environmental sound level.
In conclusion, we have successfully achieved our this report objective. As expected, The noise environment has an effect on inhabitants' quality of life. Overall, accurate traffic noise measurements support effective planning and policy development aimed at minimizing noise-related disturbance in affected areas.